Okay, so that's where these identity comes from. So the next thing we'll just discuss is the even odd formulas. Um, so I mean, basically the even odd formulas just describe how the trig functions behave when the angle becomes negative. And there's two different behaviors. So the even behavior and then the odd behavior. So for the functions that are even, which cosine is an even function, what happens is that uh, when you have a negative angle, it's same as if the angle the function behaves the same as if the angle were positive. That's what this formula is saying. And then for an odd function, which sine has the odd behavior, when the angle is negative, basically the negative comes out of the function, and you get it like this. So what do we mean by this? So even and odd is referring to the symmetry of the function, right? So there, out of the 6 trig functions, cosine and secant are the 2 even functions, and the other 4 trig functions have the uh, odd symmetry, right? So these are odd, and these are even, right? So you can see the kind of symmetry by looking at the shape of the graph, right? So here we have the shape of the cosine function, and the symmetry for this graph is if you cut the graph in half along the y-axis, then the left half and the right half are just mirror symmetries of each other, right? So you see, if I take this half of the function, I flip it around, it's exactly the same as the right half, right? So this is what we call reflection symmetry along the y-axis. And if a function has this kind of symmetry, it's called even. And you can see that secant also has the same thing, right? So if you cut the graph in half, right at the y-axis, then the left half and the right half are just mirror images of each other. So that's even symmetry. And then odd symmetry is a little bit harder to see. It's odd symmetry is rotational symmetry, right? So if you mark off the origin, and then you take the right half and you rotate it 180 degrees, then you get the left half, right? So imagine taking this half. You see, you say you take this hump in the sine function, and then I rotate it around, it'll turn upside down here, right? So odd symmetry is rotational symmetry around the origin. So you can see it for the sine function and then the other functions, right? So for tangent, if I take this piece here and I rotate it around the origin, it'll turn into this piece here. And then similarly, cosecant, if you take this piece here, you rotate it around, it turns upside down to this piece here. And then here, if you take this piece and you rotate it around, it looks like this piece. Okay, so this kind of rotational symmetry is odd. This kind of mirror symmetry is even. And that reflects, so the kind of symmetry reflects on how the function behaves in terms of negative angles, right? So you can see that if I calculate the cosine of negative 120, it's the same as calculating the cosine of positive 120 degrees, right? So these two turned out to be negative 1/2, right? So in terms of the unit circle, right? So in terms of the unit circle, right? So 120 degrees is here, and then negative 120 is actually the same thing as 240 degrees, right? Because that's the coterminal angle. And for the cosine function is the x-coordinate, right? So the x-coordinate here is exactly the same as the x-coordinate here. right? So that's basically what the even symmetry is trying to indicate, right? So you can see that the x coordinate on the top half of the unit circle is always the same as the corresponding x coordinate on the bottom half, right? So this is the same as this is the same as this is the same as this, and so on, right? For the x coordinates, right? Because basically, whether y is positive or negative, the x is the same when you're going up and down like this, right? So that's what it's being described for cosine here, and odd symmetry, right? So it says that if you calculate the sine of negative 45 degrees, it's the same as taking the positive angle, but then taking the negative of that value, right? So so basically, what this is saying, at least in terms of the unit circle, right? So sine is for the y coordinate, right? So what it's saying is that, again, you're comparing the top half to the bottom half, right? So it's essentially just saying that the y coordinate of the things on the top half are the opposite of the y coordinate of the things on the bottom half. As you can see, the y coordinate here is positive, the y coordinate here is negative. The y coordinate here is positive, the y coordinate here is negative, right? So that's what it's describing, at least in terms of the unit circle. Okay, so that's even in odd symmetry. So any questions on even and odd symmetry?
Nope.
Okay, so I mean, at least in terms of this course, we're not going to actually use the even and odd symmetry all that much. It's used a little bit in calculus when you talk about integration, because integration is referring to like areas under the curve, and when you have symmetry like this, you can see that the area here is exactly the same as the area here, and then the area here is exactly the same as the area here, right? And so if you exploit the symmetry of the graph, you can understand the area in an easier way. I mean, say similar here. The area here is the same as the area here, except this is right side up and this is upside down. Well, but in any case, we don't use it all that much in this class. So for the purpose of this section, the main